Welcome to massive open online course on cartographic technique. Myself Dr. Sivasankar, teaching faculty, Department of Geography, University of Madras. In cartographic technique, we are going to talk about map projection. Under map projection, we are going to discuss universal transfer Mercator projection. In short, we will be calling this as a UTM projection. So, here we are going to talk about the projections. Okay. So, last class we had a discussion on map projections. Let us have a small recap on this. So, what is map projection? It is a systematic transformation of earth 3-dimensional spherical or ellipsoid surface onto 2-dimensional map. So, look at the picture here. Look at the picture here. Earth is like this. It is in 3-dimensional, spherical and ellipsoid, where we are converting this 3-dimensional feature into 2-dimensional map like this. When we converting this 3-dimensional, any 3-dimensional into 2-dimensional flat surface, always there will be a distortion. We will discuss one by one. So, just conversion of 3-dimensional earth surface into 2-dimensional flat surface. So, this is known as projection. Look at the second point. This transformation is necessary because earth is in curved surface. So, when I say earth it is in curved surface, this transformation is very much mandatory. So, that we can convert that curve shape into flat like this. When you look at the third point, all projections inevitably causes distortion. Distortion nothing but the accuracy issue in terms of shape, in terms of area, in terms of distance and directions. So, none of the projection can hold all these things, because every projection has some distortion issue. Some projection will preserve shape and area, some projection will preserve distance and directions. When you talk about UTM projections, it is one type of projection for accurate for local mapping. UTM projection, it retains both shapes, area and distance. So, that is the advantage of UTM projection, universal transfer Mercator projections. With this initial talk, let us get into the history of map projection. Okay, when you look at the history of map projection, Ptolemy in 2nd century, he has created the basic version of projection. It is not, I won't be saying that this is the projection, basic version of projection. It just he has created this lat long like graphical maps, both meridian and parallels he has drawn, but we cannot say that as a projection. Okay, it is a simple he has brought map into with lat long values, that's all, where he does not follow any scientific method, simply he has done the representation. Then later on the next evaluation phase, it is on medieval map. So, look at this map, the right side what you are seeing, okay, it is completely in symbolic and highly distorted. Okay, here's they were not drawn any, so let me change the color, they have not drawn any boundary of any region, simply using the symbolic and they have created this projection system, which is highly distorted, where you cannot arrive any matrix value. Then after 16th century, the scientific projection method was introduced. Scientific means completely scientific in nature, all the boundaries and distance, area calculation, everything can be done through using these projections. So, it is complete in scientific nature, where directly you can use it on on field, okay, on real time purpose, directly you can use it. So, this is all about the history of map projection. Next, let us talk about Mercator projection. In 16th century, it was introduced by Mercator for navigation. So, mainly this Mercator projection mainly used for navigation. So, all of you know that in those days navigation played a very big role, where in terms of trade, in terms of discovering new continent, by the time this especially for navigation, for ship navigation, this projection is being used effectively. When we talk about the properties of Mercator projection, it is a conformal, which means even in last lecture we have discussed what is conformal, which shapes, which means it preserves the shapes. When you talk about the area, it will not preserve, because when you talk about the area calculation cannot be done here, where you may get the error, and it preserves direction as well. Whereas, when talk about distance and direction, where you cannot address, okay, where you can see some error. It is great for nautical chart. Okay. When talk about navigation, obviously the nautical chart will come into picture. When you talk about nautical chart, distance matters, shape also matters, everything will come into picture. When you talk about the limitation of Mercator projection, it distorts area in higher latitude. Very simple. Higher latitude nothing but if you from the equator to polar region, in equator region you can have well accuracy, where you can see the clear measurement, whereas if you are moving away from the equator towards the polar region, where you can see the distortion. Okay. It is very much suitable for equator and surrounding zone. If you are moving away from the equator, there is a chance of getting higher distortion. So, this is all about the Mercator projections. The next, in Mercator projection there are few limitations. First one is Greenland appears larger than Africa, I will tell you how it is, and not suitable for land measurement. This is the key. Okay. So, it is not suitable for land area measurement and needed new projection for land mapping. So, that only UTM came into picture. Look at the first point, Greenland appears larger than Africa. So, look at this is the actual size of Africa and this is the actual size of Greenland. Okay. Due to the distortion, look at this, looking the Mercator projection, due to the distortion, almost both Africa and Greenland it appears same in terms of, see it has retained the shapes, whereas in terms of area it is completely distorted. So, it shows that the Mercator shows that both Africa and Greenland has the same area, but in reality it is not like that. So, this is the classical and very basic example for the distortion. So, look at this map, this is Mercator projection, where equatorial area, assume that this is 500 meter or let us say 5 kilometer radius. If this 5 kilometer radius, if you start moving from equator to polar area, this circle is getting widened. So, though it is 5 kilometer radius, but due to this distortion it's keep on increasing. Even in using geospatial software, if you even you can try it lively. Okay. Create a circle for 500 kilometer and the same circle if you create close to polar region, you can see that that circle is keep on widening. Transition to UTM projection. So, in previous slide we have seen some limitation with Mercator projection. So, how we can overcome this limitations. So, when you talk about overcoming all those limitations, the universal transfer Mercator came into picture. It is developed in 1940s for military and surveying purpose. When I say military, you need to have a accurate distance measurement, moving the troops from one place to other place, that distance calculation need to be done. For that we need to have appropriate projection system. Surveying, for land measurement, the total area calculation in terms of measuring the area, this UTM projection is very much helpful. Look at the second point, Mercator upright cylindrical. So, this is a normal projection, cylindrical projection, putting a light inside the globe, wrapping the paper around the globe, only equator area get projected so nicely, so that you will be getting more accuracy in equator area. If you are moving away from the equator area, probably there will be a distortion. In order to overcome this, transfer Mercator cylindrical turn into 90 degree side waves. This is 90 degree like this and this is side way. Instead of wrapping around the equator, here we are going to wrapping around the meridians like this, in this way. We are cutting into small zones. So, we will discuss one by one, so that it will take the coverage of complete globe with minimum distortion. And look at the third point, UTM places this cylinder 60 times for each UTM zones, which means what? So, we are going to rotate like this. Okay. So, placing the placing the zone, like every zone. If you start rotating this cylindrical sideways cylindrical projection, every 60 zone like this will be will be rotating, and we start projecting every 60 zones. So, look at this picture. So, placing sideways cylindrical, and if you start rotating every zones like this, it will be captured. So, 60 times we have to rotate and we need to project. So, like that it will come zone 1, zone 2, zone 3, zone 1, zone 2 and zone 3, like that we can project. So, this picture will give the clear idea. Okay, assume that. So, this is the complete globe where we are going to slice this globe into 60, starting from 1, 2, 3, 4, 5, 6, like that, it ends with 60. So, after slicing this 60 zone into flat surface like this, when you do the flattening, okay, like this we can flatten. So, the advantage is, so we are slicing the complete globe into 60, so that we have taken very small zone area. Again we have done a flattening, nothing but projected, so that this small piece of zones has created the complete flatten of the globe, not like cylindrical projection like this. So, we are slicing into 60, so that every zones got projected so nicely, so that we can have high accuracy maps. Look at this, after slicing, so we need to have this, we have created this flat surface map, where you can see 60 zones starting from 1 and end with 60. So, this is the difference between Mercator projection and universal transfer Mercator projection. Projection type: transfer Mercator, cylindrical tangent to central meridian, is based on the central meridian. We are slicing this zone and minimize the distortion east to west within the zone. Once you slice this zone, okay, assume that this is the central meridian. So, east and west, there is a minimum distortion, because we have taken only small area, small zones. So, taking small area, when you start projecting, the distortion level will be very less. Scale factor at central meridian is 0.996. Okay, we will understand better in next slide. UTM projection scale concept. UTM uses the cylinder that cut the earth along the two lines. As I said, the UTM projection, it is sideways cylindrical, it touches the meridian along the two lines. So, this is line 1 and this is line 2, and slowly we will be rotating for every zones, we will start projecting. So, this is that tool, this is the line 1, line 2. These lines are about 180 kilometer east and west from the central meridian. So, this is the central meridian. So, west and east 180 kilometers. On these two lines, scale 1, which means 100 meter on the earth ellipsoid, 100 meter on the map, 100 meter on the maps on the earth, 100 meter on the map projection. So, both are equal, 1:1. At the central meridian here 0.9996. Example, okay, 100 meter on the earth, which is mean 100 meter on the earth means ellipsoid, 9.96 on the map, 9.96 on the map. So, the scale slowly increased away from the center. Here it is not actually 1, it is 0.996, but the scale is slowly increased from the center. So, exact scale at two lines, slightly smaller at center, larger at the end. So, like that it goes. Started with this gap, no, so this will balance, so that once it reaches the edge, no, it will become 1. So, like that we can take it. Okay, let us understand in detail what is UTM projection. So, it is a global coverage. UTM is worldwide coordinate system using transfer Mercator projection. Some projections will concentrate only on certain zones like polygonic projections. Some projections will concentrate only on the points zenithal projection or stereographic projections. Some projection will take the complete coverage of globe. So, for a very good example is UTM, universal transfer projector, which has the complete coverage of the entire globe. When you talk about the zonal division, as I said earlier, Earth split into 60 zones. So, already I demonstrated how this 60 zones were arrived, each zone's 6 degree longitude wide. So, assume that this is zone 1 and this is zone 2. Okay. So, we have arrived altogether 60 zones, this zones 6 degree longitude wide for higher accuracy. As I said, if you in order to get the higher accuracy, we are splitting the zone into small part, so that we can increase the accuracy. So, 6 degree width zone we are slicing, so that we can have a good accuracy result. Again, a metric based coordinate uses meter instead of angular unit. Metric means in meter we are arriving the numbers, whereas if you go ahead with the angular unit, it will be a degree minute second. Okay. The advantage in metric means easily we can go for the calculation, easily we can go for the measurement, easily we can go for the area calculation. So, that is the advantage of metric based coordinates. When you talk about the practical advantages, this is very important. Simplifies accurate distance, it is making more simple. If you want to calculate distance, it is very simple over here, and area calculation compared, that is also very much feasible and easy. This is if you go for any project or any work, any field work, the accurate distance calculation and area calculation is matters. Okay. Most of the scientific mapping techniques will go for area calculation and measuring the distance between one point to the other point compared to the angular unit. Polar region, stereographic projection is being used. Obviously, okay, this UTM projection will have clear coverage up to 80 degree north and south, okay, 84 degree north and 80 degree south, and beyond that, if you want to cover up with polar region, you need to use polar stereographic projections. In navigation, for example, in navigation, especially for flight live tracking and all, this complete 84 degree north and 80 degree south, where you can have a clear tracking system where it follows the UTM projections. If it is go beyond this zone, then they will be using stereographic projection in order to avoid the distortion. If we look at the coverage already discussed, 84 degree north and 80 degree south. So, beyond that you may have the distortion accuracy issue. So, this is the overall picture of UTM projection. Central meridian. So, let us understand what is central meridian. Each zone has central meridian at the midpoint. Let us understand this better. So, this is one zone. Okay. I said we have sliced the entire globe into 60 zone. Assume that this is one of the zone. The midpoint of this zone, we can call it as central meridian. I will be telling you like why we are using this central meridian, how it's play a crucial role in UTM projection system. Example, zone 44 degree north, 81 degree east, it is a Chennai, we will discuss in upcoming slide, and used reference for easting and northing. Okay. Easting and northing we will discuss. So, easting and northing, it comes under coordinate components. So, here in UTM projection, something called easting called x coordinate, northing called y coordinate. We will understand this better. Measuring eastward from the central meridian, okay, measuring eastward from the central meridian. Obviously, you know what is central meridian, this line, this particular line, it is a central meridian. It is a midline of any zone, this is the zone boundary. So, this black color line, it is a zone boundary, and this blue color line, it is the central meridian. So, this is the midpoint. 500 meter false easting assigned to central meridian, so that the coordinate remains positive. If you fix the central meridian here line, this is 500,000 meter. Look at the value here. and before that we have to understand northing, easting, and we have to understand what is northern hemisphere, southern hemisphere. This is southern hemisphere, this is northern hemisphere, this is equator, and this is the central meridian where latitude 0 equator, and central meridian 500,000 meter east. This is the arbitrary value which has been assigned for every central meridian. 500 meter east, easting, x coordinate easting, and this side easting, and this side west, and this is the equator. This is for easting, and when I say northing, from the equator, the northern hemisphere, it starts from 0, and southern hemisphere it starts from 10 million, and this complete zone from the central meridian, this is minus 3 degree and this is plus 3 degree. So, let us understand these numbers. So, this is central meridian numbers, just now we have discussed, and this is the starting point of the zone, and this is the ending point of the zone, where the latitude value remains 0 degree, and central meridian minus 3, because from the central meridian minus 3, and if you talk about the easting, this is 166,008 meter from the east. When you talk about the the other end, it is about 833,992 meters. So, this is how it has been calculated, this is how it has been arrived, and northing, as I said earlier, from the 0 degree, from northern hemisphere it starts from 0, and southern hemisphere it starts from 10 million. So, accordingly the numbers will be changing. If you are moving from one point to other point, the numbers will be changing. Easting and northing, from the equator it is, if you take this 6 degree in equator, almost 688 kilometer width. If you are moving towards the north, it is 116 kilometer. So, this is India. India has 6 UTM zones starting from 41, starting from 42 and ends with 47, and minimize the distortion. Each zones cover the limited area, so that earth curve flatten. So, each zones covers the minimum area. So, easily we can flatten, we can minimize the distortion. Each zone is 6 degree, so that easily we can go for flattening, so that the curve structure of every zone easily flattens, so that we can minimize the distortion. High accuracy, since you are using UTM WGS84 datum gives the better distance. If you started using WBS84, it will give the better distance and area measurement. As I said earlier, distance and area measurement, it matters. So, this is adopted by Survey of India, both they are combination of UTM and WGS84 and open series map, making this a standard system. And again, this is globally aligned. If you work with any part of Indian maps, it is automatically aligned with the global accuracy or global projection system. So, all India, all the zones will fall under northern hemisphere. And finding the UTM zones and central meridian. So, this is the, in order to find the UTM zones, in order to find the central meridian, this is the formula where you have to use this formula, zone equal to longitude plus 180 divided by 6 plus 1. So, that is for identifying the zones. For central meridian, this is the formula, 6 into zone minus 183 degree. Let us say for example, Chennai, this is the longitude value 80.3 degree east. Apply this number in this formula where we can use where you can use this longitude value 80.3 degrees and 180 divided by 6 plus 1. So, this is the number which you are having 260.3 divided by 6 plus 1, and finally, you will be getting the answer 43.38 plus 1 equal to 44. So, the 44 is zone, we belongs to zone 44. Then in order to arrive central meridian, 6 into zone nothing but 44, we got it here, minus 183, then 264 minus 183, 81 degree east. This is the central meridian. Assume that this is zone 44, this is central meridian 81 degree east. If you are reporting Chennai in terms of UTM projection zone, you have to write like this. Okay, WGS 84, Everest 1830 and UTM zone and 44 degree north and central meridian 81 degree east. So, this is the easting value, this is the northing value, and already I have demonstrated how we can calculate easting and northing value. The advantage of UTM projection, minimal distortion within the zone, because zone is very small. Okay, so there is a minimum distortion in terms of west or east, whatever it may be, metric based. Okay, metric means, as I said, no, it is a meter. In terms of meter, we can have EC area calculation and distance, globally standard, used in GPS systems, widely adopted in survey and mapping, any survey, land survey, drone survey, whatever it may be, where we are using this UTM projection effectively, not to get the precise result. Application in India. So, Survey of India adopted this UTM with WGS 84 datum, used in open source. Already we have seen this, more accurate than the older polygonic projection. So, in previous we were using polygonic projection. Now, compared to polygonic projection, UTM will give better accurate result. Application of UTM projection, surveying and engineering, as I said earlier, in terms of area or area calculation or distance calculation, very effectively they are using. Construction, infrastructure projection and all, UTM projection will give excellent result. So, navigation widely they are using, and military operations, disaster management, okay, for relief and rescue, in order to pinpoint the location, in order to pinpoint the distance, in terms of calculating the area of area of affected zones. For every action we can do, we can have UTM projection as a base, not to get the better accurate result, and using GIS remote sensing. Okay, standard projection for spatial analysis in many software tool. Okay, if you are using any softwares, both in terms of image processing or any vector based processing, both GIS and remote sensing, this UTM projection is playing very crucial role in terms of land measurement. So, this is for plotting UTM coordinates for Chennai. Already I have given this zone 44, CM central meridian 81 degree east, easting, and this is the easting value and this is the northing value, this is the unit in meters. Okay, measuring the unit in meters. That is why I am keep on telling that for any measurement unit, it is going to help you, like easily we can get the accurate result. And UTM versus latitude longitude, just we are comparing metric with lat long system, where UTM units is meter, here it is degree minutes second, distance easy, whereas distance calculation somewhat tedious. In terms of accuracy, local level, let us say it is as I said, local level accuracy, it is very high in UTM projection. Okay, if you global but less, when you lat long value, global level, there is some challenges. Use cases, survey and GPS, and navigation and global map. These are the advantage: high accuracy per zone metric system, widely adopted, and limitation, zone based. Cross zone calculation comes somewhat tricky and very tedious, not suited for polar region. This is because in polar region we can see more distortion, and this is plotting the UTM projections. So, already we have seen it, projection type, transfer Mercator, zones, 60 zones, 6 degree wide, unit in meter, and false eating and false northing, scale factor and coverage. And global case study, GPS navigation, UTM used internally for many navigation purpose, application aviation, vehicle tracking, effectively we are using it. Indian case study in urban planning, disaster management in terms of cyclone relief, infrastructure, everywhere we have started using it. So, these are the key takeaway. UTM equal to transfer Mercator projection is for global zone system. It provides accurate and metric based mapping. For any scientific mapping, it gives more accurate and metric based. Standard GPS, surveying, GIS, remote sensing, everywhere we are using it. Okay, because everywhere and we need to have measurement in terms of area, distance, whatever it may be. For every standards we are using it, and India follow UTM with WGS 84, and it is globally aligned. So, with this we had understanding on universal transfer Mercator projection, and we have seen how it works, how the metric system will works, and what are the advantage we have seen and what are the limitation we have seen, and real time application where and all we can use it effectively. So, everything we have discussed. Thank you.